Hi there. Today we'll learn about types of chemical reaction. Okay. So the chemical reactions are majorly classified into 5 types of reactions. Okay. That is combination reaction, decomposition reaction, displacement reaction, double displacement and redox reaction. Okay. So combination. The name itself says that combination. So two or more reactants combine together to form a product, right? Combination. Decomposition. If a compound is there, under some condition it will be split into two or more substance. Displacement. Displacements mean what? Changes. It replace some other place, some other metals or something. It will be displaced. Double displacement means if two compounds are reacting, both the compounds will elements in the both the compounds will replace. Okay. Redox means reduction and oxidation both are taking place in a reaction. Okay. So combination means only if you combine a thing, two or more reactants, only one product is formed. Okay. So likewise, decomposition means only one product is split into two or one reactant. Only one reactant compound is split into two or more products. Displacement means when the displacement will take place means more reactive elements displaces less active elements. Okay. So if a less active element is present in the compound, it will replaces that. Okay. Double displacement means exchange of ions will takes place. Okay, exchange of ions. If compound is a neutral one, right? It contains both the positive and negative ions, right? That ions will exchange each other. Okay, and redox means reduction and oxidation both takes place there. Okay, so we'll see one by one in detail. Okay, so what is combination reaction? Combination reaction means we said that two or more reactants. For example, so this is one of the element and this is one of the element, right? These are the reactants will combine together to form a one product, right? Single product is formed in a combination reaction. Okay, not only elements, you can combine the element with another compound, right? So it react together to form a single compound. This is one of the product. Okay, clear on this? This is your combination reaction. Okay, so we'll see some examples. So what is combination reaction? Two or more substance combine to form one substance, right? Only one product is formed. So hydrogen plus oxygen gives water molecule, right? Hydrogen plus oxygen gives the two reactants combine to form one product, right? Is it balanced form? Here 2 oxygen is there, here only 1. So we'll make it to 2. So this hydrogen become 4. So we'll make the hydrogen 4 in the reactant side also. Okay, clear on this? So two reactants combine to form one product, right? Likewise, magnesium plus oxygen reacts to form magnesium oxide, right? So two reactions combine to form one product. Okay, so here also it is not balanced. If you put 2, it becomes 2 oxygen here, it becomes 2 magnesium here, we'll make it to 2 magnesium in the reactant side also, right? Okay, next, these are this hydrogen element reacts with oxygen element to form a compound, right? Here the compound plus element, this is carbon monoxide plus this oxygen will give carbon dioxide. Compound plus one element will give another compound, right? So here how many? Here all 3 oxygens are present. Here only 2. One carbon is present. One carbon is present. Make it to 2. Becomes 2 carbon. So 2 oxygen plus 2. So totally here also 4 oxygen is there. Okay. Now it is balanced. Likewise, sodium plus chlorine. Sodium plus chlorine gives sodium chloride. Okay, NaCl. So two reactants react to form one product. These are the examples of a combination reaction, right? Two or more substances combine to form one substance. Okay. Next. Next one is your decomposition reaction. That means what? One compound breaks into two or more simpler substances. That is exactly the opposite of the combination reaction. So what is that? For example, this is a compound. For example, this is a compound. After decomposition, it's split into two or three products. Okay, this is one product, this is one product, this is one product. Okay, or one compound plus a one element, right? So this is your decomposition reaction. Okay. So one compound break into two or more simpler substance, that is opposite of the combination reaction, is the decomposition reaction. See, take down. Calcium carbonate in the presence of heat, it's decomposed into, that means split into calcium oxide plus carbon dioxide. Okay, since it takes place in the presence of heat, we can call this reaction as thermal decomposition. Okay, you can say this is a decomposition process. Okay, what type of decomposition? Thermal decomposition, because it takes place in the presence of heat. Okay, calcium carbonate, it is a compound which splits into two compounds, right? Calcium oxide plus carbon dioxide. Okay, everything is balanced. One calcium, one carbon, and here 3 oxygen, here also 2 plus 1 3 oxygen. So it is balanced. Okay, now next one. So water molecule, it is a compound in the presence of when electric current is passed, it's split into hydrogen plus oxygen. Okay, so one compound is split into two simpler compounds. So since it takes place in the presence of electric current, we can call this as electrolysis of water. Okay, 4 hydrogen, 2 oxygen, here also 2. This is balanced. Okay, next, silver chloride in the presence of sunlight, it decomposes into silver plus chlorine, right? This in the presence of sunlight only, when exposed to sunlight only, it will decompose, right? We use this reaction in this black and white photography. So if the film contains silver chloride, when you expose to light, the black and gray color will be formed, right? Black and white photography will be formed. Okay, 2 Ag, AgCl, it is balanced. 2 Ag is here also 2 Ag, 2 Cl is there, here also 2 Cl. Okay, so silver chloride in the presence of sunlight, it decomposes into silver and chlorine. Clear on this? Okay, next, displacement reaction. So what is displacement reaction? More active elements displaces less active elements. It is also called single displacement reaction, because we have one more reaction that is called double displacement reaction, right? So this is called simply displacement reaction, means it is nothing but your single displacement reaction. So we'll show with some example. For example, this is a compound, this is an element. This element is very active element. What it will try to do means, this is a less reactive. For example, this green color is a less reactive element in the compound, means it will replace us. So it will replace us and it will combine with this. Okay, this is your displacement reaction. Okay, this is a very active element, this more reactive element, so it replaces the less reactive element present in the compounds. What is this? It will replace us and it will be combined here. This is your displacement reaction. Okay, this is called single displacement reaction. Okay, so what is meant by displacement reaction? more reactive elements displaces less active elements. It is also called single displacement reaction. So, we said more active elements will displace less active elements. How to find which is more and which is less active? Okay. So, we have a reactivity series in a chemistry. Okay. Reactivities of the metals and also non-metals also present. Okay. So no other way, you have to by God this one. Okay. Which element is more reactive than other? Okay. Reactivity series of metal. Okay. So this is the most reactive element. If it goes down, the reactivity will reduce, and finally we have gold here. Okay. So this is your reactivity series. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen. But here hydrogen is a non-metal. It is a non-metal. But since it acts as a electropositive elements, it replaces some metals. Okay. So we are placed here copper, mercury, silver, platinum and gold. Okay. This is the reactivity series of metals. This is potassium is the most reactive element metal, and gold is the least reactive metal. Okay. Likewise, in the non-metal side also, fluorine is the most reactive and iodine is the least reactive. That reactivity decreases like this. Okay. For example, this chlorine is more reactive than bromine. Chlorine is more reactive than iodine. So this is most reactive and this is least reactive. So based on this, we can say which one will replace which one. Okay. Let's see some examples. Okay. Okay. We are having zinc. We are having zinc plus hydrochloric acid. HCl means what? Hydrochloric acid, zinc. We'll see the reactivity series, which is more reactive. See, look at this. Zinc is placed above the hydrogen. So, zinc is more reactive than hydrogen. So, what will it try to do? So, it tried to displace the hydrogen present here, right? So, it will combine with the fluorine. So, it will try to replace this hydrogen. So, ZnCl plus H2. Okay. So, it is not balanced. So, we will make it to balance 2 HCl. So, this Cl becomes 2 zinc chloride. Already Cn is a zinc chloride plus hydrogen gas. So here 2H is there, 2Cl and Z1. Okay. Now see, zinc is more reactive than hydrogen. So it replaces the hydrogen from the hydrochloric acid and form zinc chloride plus hydrogen. Clear on this? Okay. Likewise, potassium iodide plus chlorine gives. So we see this reactivity series, which is more reactive. Potassium is most reactive one, right? Potassium replaces here chlorine is present, non-metal is present, right? Non-metal. Chlorine is more. It tried to replace the iodine present here, because chlorine is more reactive than iodine. Okay. So actually, this is example of non-metal. So what will this chlorine try to replace the iodine? So potassium chloride will be formed plus potassium chloride plus iodide. Sorry, potassium KCl1. Okay, right. Potassium is also one valence. The compound will be formed based on the valence. Okay. So KCl, potassium chloride plus iodine is formed. So this will become 2 KCl, 2 I is there, 2K is there, 2K is there, Cl2 is there, 2Cl is there. Okay. So this is an example of a displacement reaction of a metal, and this is a displacement reaction of non-metal. Okay. Clear on this? Next. What happens when iron nail is placed in copper sulfate solution? Okay. Iron nail is placed in copper sulfate solution. This is iron plus copper sulfate. So we'll see the reactivity series. Iron is here, copper is here. So iron is more reactive than copper. So this iron try to replace this copper, right? So what will happen? Iron sulfate will be formed plus iron sulfate and copper. So this iron will replace this copper because iron is more reactive than this copper. Okay. As you know this is blue color. Copper sulfate is blue and this iron sulfate is green in color. So because of this, this copper is, you can see this when the iron nail is placed in the copper sulfate, a reddish brown, because of this copper, a reddish brown deposits are can see in the nail. This is copper is reddish brown in color. Reddish brown. So 1 Fe, 1 U, 1 SO4, 1 SO4 plus Cu. Okay. What will happen if copper is placed in an iron sulfate solution? So look at this. Copper is here, iron is present here. Copper is less reactive than iron. So it cannot replace Fe from FeSO4. So no reaction will take place.